Okay, good morning. Thanks for coming. I would like to remind you of a concept that we used in previous presentations in this natural resources day, which is the concept of narrative. This is very important because this is how we human beings think. We don't think like computers, we don't make equations, we don't sample the data, and this is not how our brain works. Our brain works with narratives. What is a narrative? A narrative is an explanation. It's an explanation, so it has causality that explains to us what we see. So this happens because now when we do not know why, we just make it up. The sun comes up because there is a chariot of fire going around. Now, eventually, we realize that that is not true, that the sun comes up because the earth is round. But until we knew that, we thought of other things. We always have to have explanations. Human beings cannot handle not knowing. The last thing that the boss says is, I don't know. The boss is paid to know. You know, a politician is paid to know. No politician says, I don't know. When in reality, they don't know most of the time. We don't know most of the time, and the world is very complicated. But we need narratives, okay? So narratives get established. For a narrative to get established, it has to be repeated very often. It has to give an explanation for what we see, and it has to fit our previous preconceptions. Because nobody likes to change preconceptions, because this is hard work. Now, I'm going to talk about narratives on oil. Today, the narrative is very simple. You know, we can come here, like Alex did at the beginning, and show to you that natural resources companies are extremely inexpensive. I mean, that is a fact, the PE, all that, the numbers, you can divide it by the S&P, anything you want. But that's been the case for 10 years. So that doesn't, therefore, the fact that they're very cheap doesn't mean that they're going to go up tomorrow, because they've been very cheap for 10 years. But why is that so? Why are people not buying that? Why are they buying this Vietnamese car company that sold all of 5,000 cars last year and has a market, no, seriously, and has a market cap of 4 times General Motors? Narratives, because they're the new Tesla. Okay, I know Tesla, I know those guys got rich, yeah, that makes sense, I'm interested in that. Now, why are oil companies so inexpensive? Because everybody knows, it was in the Financial Times yesterday, but it is every day, in every newspaper. Everybody knows until in 2030, 35, there won't be more use for oil. Now, a company that is producing a product that is making a lot of money, but in 10 years' time is going to be out of business, does not deserve a very high PE, obviously. Arithmetically, at most 10, if it's going to be out of business in 10 years' time. And that is a narrative. And that narrative is constantly reinforced by everything we see. If we get no rain during the summer, it's because of weather change. If we get floods, it is because of weather change. If we get fires, it's because of weather change. If we get thunderstorm, anything we get is weather change, which means oil companies must stop producing oil. So therefore, who is going to invest in that? Everything will be done with copper, which Alberto now just told you that cannot be done because there is not enough copper. But that narrative doesn't, that is one of the things that you leave out, because it does not fit with the narrative. Now, so we're going to talk about peak oil. Peak oil, something that was introduced in the 50s by a shell engineer called Herbert King. And his idea was very simple. If you take any natural resource, you take, as they call it, a reservoir, a place where there is oil, and you start extracting oil, as you start, you produce a little bit more oil at the beginning every year because the thing gets more productive and you produce more. But at some point, and this is an empirical, I'll give you some examples, it starts producing less, and eventually it is empty. It doesn't produce anything. So you get a curve. You know, you are not producing anything, you start producing, produce, and then you start doing less, and eventually there is no more oil. Now, can we estimate that if we know how that curve what shape is it going to have, we know when the peak is, so we know when we cannot produce more oil. Okay? We can produce more in the sense that the next year we will produce, but we will produce less than this year. So it will be the peak oil. And this is just common sense, you know, you empty something and eventually there's nothing. Now, Hubbard's interesting idea is that he realized that that applied to an individual oil field, or to a whole region of oil fields, like Texas, which is where he used to work, or to the whole country, the US, or even to planet Earth. And through some relatively sophisticated math, he came to the hypothesis, this is a hypothesis, it's not a law of nature, but the concept, you know, the realization that once you have produced more or less half of the oil that was in place, it starts going down. So the whole curve really looks like a bell curve. You know, you go up, and when you get more or less to the middle, you start going down. He took the thing, and he said, okay, this is going to, he did the numbers for the US and said the US is, and this was in the early 60s when the US was the world's largest producer of oil, and he said it's going to top in the early 70s, and then it will go all the way down, which it happened. And then, of course, he looked great. And everybody thought, wow, wasn't this guy smart? And then we'll see what happened later on. Today, he's considered to be an idiot. We'll see why that is not the case. Now, the message we want to pass, and what I'm going to try to support, is that the current narrative about oil is completely wrong. Now, to go against the narrative is one of the best ways to waste your time. Because as I said before, narratives are what human beings use to survive, actually. So you don't want to change your mind, but you're wrong. In the previous year, we had, I made a presentation talking about energy in general, and I'll go through this very fast, not to repeat myself. Energy equals civilization. The only reason we're dressed and we have a tie and we eat 3 times a day and we're healthy and we live now 80 years and blah, 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 is because of energy. Energy is what's behind growth in GDP, what's behind on any human development variable that you want, and last year we explained that in detail. But there is a kind of energy, you know, energy is a kind of a very, in fact, it's very difficult to define. Energy is a generic word, you know. But not all energy is the same. Some energy is fungible. I mean, you can use one type of energy or another type of energy to do the same job. But some other sources of energy are not fungible. You cannot swap them. You can make electricity with a coal plant, with a hydropower, with a nuclear plant, but you cannot run a car with hydropower directly. It cannot be done. Or with nuclear, or even with natural. Well, natural gas, it theoretically could be done, but it cannot because they're not prepared for that. Now, there is a source of energy, which is oil, which is not fungible, at least not in the short or medium term. You cannot put coal in a truck. You know, right now, today, diesel prices have doubled because there is not enough diesel, and but that doesn't mean that you can put coal in your. You can do that if you have a diesel power generation plant. Many of them are built to be able to use different fuels, and then you can buy coal, but not for your car. So for much of the use of oil cannot be substituted by the other. And why is that? Because oil is one of the most expensive sources of energy, because it is one of the best sources of energy. So every substitution that could be done has already been done. Okay. 50 years ago, there were lots of electricity plants using fuel oil. You know, it was fuel. One way to nobody does that anymore except when there is not enough other things. It is really the last, because it is the most expensive. So oil is a bit special. Now, in 2019, people thought that that was it. And in fact, it was published everywhere. The International Energy Agency, the same who published yesterday, said 2019 was the peak in oil demand. And this is what it looked. Well, of course, it was not. Today, I mean, it's 2023, we're going to break that by several million barrels per day. We're going to 103 million this year, and it's going to keep going up. And as I said before, most oil is used for transportation. And now we go into narratives. Very few of you, I guess, this is just a guess, but I'm pretty sure, own big 40-ton trucks. I mean, it is something that only if you are a shareholder in a transportation company you will own some. Otherwise, you don't own them. So you don't have an intuitive sense of what is going on with the truck. But all of you own cars and put gasoline, or all of you can buy, and in fact, I'm sure some of you have bought, an electric car. I mean, it's an option. It's something that is part. And now, that is the part that leads people to think, okay, I used to drive this big thing, now I have this electric car, I don't use gasoline anymore, so yeah, gasoline consumption must be going down because, you know, everybody's going the way, this is the way everybody's going. And since this is the narrative, the thing that, the facts that we see every day, we extrapolate and say, yeah, I'm not going to invest in oil companies because, you know, I am buying a Tesla, so why would I invest in an oil company? Because, yeah, electric cars little by little are coming in. I underline the word little by little. A car, and we'll go to some numbers, a car lasts about 25 years now. I mean, probably not your car, but when you sell it, you don't burn it. You sell it to somebody who keeps using it and keeps using it. And if you go to Morocco tomorrow, you will see that all the taxis are old Swiss cars, you know, that are ending their lives there. In fact, many cars last today more than 25 years. But let's assume 25 years as a round number. That means that if all the cars sold tomorrow were electric, all of them in the world, the 100 million, well, it's in fact 50 because half of it is trucks. All of them were electric. That would mean that the car park, the whole, you know, bunch of cars in the world would be 4% electric and 96% gasoline. So you would say, yeah, we are now at 100% electric vehicle penetration, sure, but you are still at 96% consumption of gasoline. By the way, many of the data with electric cars are fake, like most things about renewables, because they put together battery-powered cars, like a Tesla, with plug-in hybrids, with hybrids. Now, plug-in hybrids and hybrids use more or less the same, a bit less gasoline than normal cars, but they keep using a lot of gasoline, mostly because they have very heavy batteries that they have to carry around with gasoline when they are on the gasoline mode. I've owned two big hybrid Lexus cars, and in the city running, they spend much less. That's why you see many taxis, particularly in Geneva. We were cheaper than here. You see many Lexus and many Prius, Toyota Prius hybrids, because in the city, since you brake a lot and you don't go very fast, you can use the electric thing a lot. But the moment you go to the motorway, it uses much more essence than the normal model because you have these huge batteries with you everywhere. So anyway, let's just take it at face value. Now there's a country that stands out, and we're going to say a couple of words about Norway. See how the reality fits with the narrative. Norway is a country, as you probably know, even more than Switzerland. It gets all its electricity, almost all, from hydropower, because they have lots of mountains and a lot of snow, much more even than we have here. So they use a very green, in fact they export like Switzerland, but they don't import. They really export a lot of electricity because they have plenty of hydropower. And then the government, probably because they have bad conscience because they are the wealthiest country in Europe because of oil, so they don't feel good about it. So they've given enormous amounts of incentives for people to switch to electric cars. So they're subsidized. You can park in places where gasoline cars cannot park. You don't have to pay tolls in the toll roads. You don't have to pay taxes, blah, 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 blah. And, I mean, people are not stupid, you know. If you give me something for free, I'll get it. So penetration in Norway is very high. This is the numbers. These are the real things. Battery electric vehicles. I mean, real, not the plug-in hybrids and those things. 80% registrations. So that's new cars registrations. What's being registered every year. I mean, that's just 1 month, but it gives you an idea of where the market is. So there you have a country where the narrative has already happened. Okay, people now just buy electric cars. And this is Norway's oil consumption. Okay, this does not fit the narrative very well. According to the narrative, we should be here now, because nobody is buying gasoline cars. Well, look at where we are. Now, why are we there? Well, first, you have this effect, of course, which will disappear in time, but the effect of the cars that are already there, as I said before. Second, and this is very funny, well, not the case so much in Norway, but most people who have an electric car is their second car, because you need a real car when you want to travel. So you have an electric car when you're very wealthy, and you can not only pay for an electric car, but it's like renewables. You can pay for the windmill and the gas plant to back it up. Otherwise, you cannot do anything with it. And then, of course, you have trucks. Now, trucks are kind of, as I said before, not a very sexy topic. Nobody knows anything about trucks, but we all depend on trucks. All our food comes in trucks. All means all, 100%. No trucks, no food. We all die. That's it. About in a week. That's what it would take. The whole industry, the whole commerce, transportation, all depends on diesel. And Norway, of course, the Norwegians keep eating, and they have this wonderful salmon in which we invest a lot. But you have to take the salmon actually out of the water and take them to market and then cut them. And all that you do with trucks and using diesel, which they keep doing, of course, no matter how many electric cars they buy. So, and this is the reality of the world, because part of the narratives, as I said, narratives help us interpret the world that we see. But the world that we see right now is Zurich. And if we are very open-minded, Switzerland and even Europe. But the world is a bit bigger than that. It is a bit bigger than that. And I'll show you how big it is. But these are the per capita consumption of oil. It's going down. It's gone down in the US, which was the worst, obviously, waster of oil in the world. You know, since the oil crisis, obviously, they started putting insulation and doing things like that, but then it stabilized. It has stabilized more or less at 30 megawatts. And then Japan. Japan is a country, as you know, that has no capacity to generate electricity. They have nothing. They don't have hydropower. They don't have anything. So it's the only developed country which used to burn a lot of oil to produce electricity, because they have to import it, and it's relatively easy to do. And of course, as oil has become expensive, they've been going more for natural gas for a while, to nuclear, and then consumption's gone down. European Union is pretty stable. And then you see, of course, the poorer countries. Think of, I mean, this is trying to do some numbers to try to break the narrative. I mean, what I put here, this is just numbers. I mean, you could make different numbers, but it will give you an idea of the direction of things. You know, there are about 1 billion cars in the world, cars and trucks, right now. I mean, that is a fact. Then sales used to be 100 million per year, more or less. Then with the COVID, the whole thing went down, and now they're recovering. So let's say they go back to 100 at some point, and then they grow by 1% per year, 1-2%. And then the penetration of electric vehicles. 50% means all cars, because half of the vehicles are trucks, and there are no electric trucks for very good reasons. Then you have amortization. I mean, some cars being taken away every year, 5% more or less, because they're already too old, 4 or 5%. And then you have how many non-electric vehicles you have every year. I mean, how many gasoline-powered cars you have. And what you see is that the final, these are sales, and so the final stock of non-electric cars, I mean, how many gasoline cars with these little numbers, which you could change, you will have in the world, keeps going up. Even when all the cars are electric, it keeps going up. So demand for gasoline is not going to go down. No way, not in the next 20 years. It just cannot happen. And that is for gasoline, which this is important to point. Gasoline, we're discussing, the narrative talks about oil when what the narrative is explaining or thinking about is gasoline. Gasoline is a fourth of the whole thing. Diesel is not affected by the narrative, certainly not plastics or many other industrial uses, which will continue going up. In fact, this is a very interesting chart. I'll explain it. It's a bit complicated, but what you have on the upper, I mean, I mean an analyst, but I copied it. An analyst divided the world in 5 chunks of more than 1 billion. This is not the whole world. There are other countries which are not represented here, big ones like Russia or Turkey. You have 1 billion people, which this guy called the lucky 1 billion. That's us. Us and the other Europeans and the Americans and the Japanese and the Australians. This is the lucky billion. Then you have China, 1.4 billion. Then you have India, 1.4 billion. That's something I did not know. Southeast Asia. So Asia, without China, without India, and without Japan, it's 1.3 billion. Because you have places that you don't think too much about probably, like Bangladesh, 200 million people, Pakistan, 200 million people, Indonesia, 200 million people. And then Africa, another 1.4 billion people. Then the second line is the estimated population in 2050. Unlike oil consumption forecast, I mean, this is a relatively safe forecast because, you know, the children who will have 40 years and who will be 40 years old in 40 years' time are already being born. I mean, we know how many people there are. So you can calculate that. That will be the population. You see the lucky billion staying flat, basically, China going down, in fact, and then the other things growing. Of course, Africa is the only part of the world that is growing very, very fast, from the point of view of births. Now you take the oil demand, this fourth line, you take the oil demand per capita right now. It is 3.3 barrels a year for the lucky, which is heterogeneous because the Americans consume much more, but that's an average. 3.7 in China, 1.4 India, 3.2 Southeast Asia, 1.1 Africa. Now, what are these guys going to do, China, India, Asia, and Africa, in the next 30, 40 years? And what they're, I mean, nobody knows what they're going to do because nobody knows the future, but I know what they're going to try to do, is to be a little bit more like us, is to be a bit richer, like we are going to. But to them it's easier because they're much poorer, so they're going to go up. Now, how much are they going to grow? Nobody knows. You can take any assumption you want. If you think that they will go to 3 barrels per capita, that would be the added demand. If you think that they go to 5 barrels per capita, which is still a third of what we use, this would be the added demand, and if they go to 7.5, which is half of what we do, that would be this would be the added demand. In the case of the rich world, if we go to 7.5, we decrease, because we're using already 13. But of course, they would increase, because they're using much less. Now, the reality will be a combination of these numbers. I mean, some places will grow faster than others, some places may not grow. I mean, who knows? But this would be the numbers. You remember, today's consumption of oil is 103 million barrels per day. If Africa went to 5, that would add 30 million to the current demand. Okay, so, and these are some numbers, and you can change. I mean, you can take any estimation you want. But what is not going to happen is that those guys are going to say, yeah, the world is warming, let's stay poor forever. I mean, that is not going to happen if they can do anything about it. Okay? So, conclusion for the narrative on peak oil demand is that we don't see it. It will come. I don't think that in 300 years' time we'll be using oil. We'll be using something completely different. But it is not something that is going to happen in your investment horizon, put it this way. The International Energy Agency, which is one of the funniest things in the world, paid with our taxes, by the way. In 2021, I mean, that's 2 years ago, they said that the peak was in 2019, and in 2030, so in 7 years' time, we would be at 75 million, which is not a bad drop. Now, they say that it's not going to be 75, sorry, we made a mistake, it's going to be 110, you know, a rounding error, you know. So base your investment decisions on whatever these guys say, and you'll get very, very far. They said yesterday that we are going to see peak use of things this decade. Fine. I mean, they can say whatever they want. Now let's talk about supply. Because as an investor, obviously, you want to make money. To make money, you need a high oil price. And to need a high oil price, you need two things. You need demand, but you also need supply. If there is plenty of oil, as we saw 2 years ago, oil can be free, in fact, if people don't know where to put it. And this, of course, this is the story that Alberto was telling about copper. Well, it is basically the same story about oil. It's actually probably worse in oil because copper is now acceptable within the green narrative. Oil is still not acceptable. So it's even more difficult to invest in oil than to invest in copper from a social or political point of view. The truth is that, and that is something that people forget, Alberto mentioned it, there is depletion. You know, a cookie factory, as long as you maintain the machines, can produce cookies forever. But a copper mine or an oil field cannot produce forever. After a number of years, depending on how big the thing is, it's empty. That's it, there is no more. Now, every year, some fields become extinct. And that depends a lot on how fast that happens, how many you get in a particular year, depends a lot on how much you reinvest, because you can always get a little bit more oil, spending more money out of the place until it's really, truly empty. And that's called depletion. And now depletion, it depends on the year, as you see in the curves on the right. But it averages about 5%. So that means that every year, you lose 5% of production capacity, which means that every year you have to increase. I mean, you need new production of 5% to stay even, not to produce more, blah, 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 no, just to stay even. Now, 5% would be 5 million, more or less. That would make you the 4th largest producer in the world. And we need one every year, a new one, every year, every single year. The moment you stop investing, well, nothing happens, but you start losing that, and eventually it catches up with you. And this is what is happening right now. So, number of projects under development, production growth, and these are sobering numbers. In the last 20 years that I have been in our company, we have been working on this field, we have seen basically three. One is, of course, shale oil, which is a story to tell apart, very interesting. But normal oil, two big discoveries. In Brazil, what they call the pre-salt, which is in the ocean under a thick, thick layer of salt. Nobody knew there was oil there because the salt made it impossible to do seismic studies. You know, the way to find oil is, well, it's complicated, but it's like an echogram, what you do with babies, you know. An echogram, and then you send some noise, and you say it comes back, and a computer makes up what's down there. Now, the salt layer prevents these things from going down, so you don't know what's in there. Until somebody got the idea of attacking the thing, you know, if the layer is here, from here. So from the sides, very complicated. Anyway, they found oil, and there's a lot of oil. Nobody knows how much, because it's very far away in the ocean, but there are some estimates, of course. And the estimates vary from 50 to 100 billion barrels of oil. Unrisked, that means the whole oil that's there, then we have to get it out. And then later, in Guyana, fortunately a company that we owned, found a lot of oil, Exxon and Hess. Now, that would be about 11 billion. Now, to give you an idea of how much oil that is, the world uses 36 billion per year. So 100 million per day comes down to 36 billion per year. Now, if every 20 years we find 100 and we consume 36 per year, well, this is not going to work. Okay? And then, of course, is the amount of oil unlimited? Will we go on discovering things as we need? This is the curve that King Hubbard produced in the early 50s. The dotted line was his model, and then the solid line is what happened. Now, what happened is that, I mean, everybody was very impressed because the peak was exactly what he had predicted. But then Alaska came. I mean, they found oil in Alaska, which was not part of the calculations because nobody knew there was oil there. And there was a lot of oil. So production went up, but then it started going down again. But of course, at a much higher level than he had expected, because this difference between the two lines is the annual production of Canada. And then this is what happened. You got shale oil, and look what the curve did. But the question is, it did that because he had not taken shale into account, because it was not supposed to be commercially viable. Now, once you put shale into the equation, you get back to the same model. Now, the question is, will you find another shale? And your guess is as good as mine. Probably not as good as mine, because I've been studying the thing a lot. And my guess would be no, but it could be. But my guess would be no. But anyway, that's it. Now, how much oil? You see, this used to be, when we started working in this field, Cantarell, which is a Mexican field in the Gulf of Mexico, was the second largest in the world after Ghawar in Saudi Arabia. And now look at their production. So fields do get depleted. Now, in the end, whether we can turn the curve around again and go up will depend on how much. By the way, practically everybody is decreasing oil production. It's not only Mexico and Cantarell. United Kingdom, Venezuela, Angola, Nigeria, Iran, almost everybody is going down. And only basically 4 or 5 countries, 6 countries hold production. In fact, if shale oil had not happened, we would have seen oil at $300 per barrel a long time ago. But it did happen. Now the question is, will it happen again? And again, if you think it will happen again, go short, you know, but we'll see. But there are very few countries putting it. So obviously, how much oil there is apparently this is like an empirical fact, you know, how much oil is there in a bottle? Well, you can measure it. How much oil is in the earth? In fact, does not take one single answer, because it depends, of course, of how much oil there is. That's a geological fact, and that doesn't change from one year to the next. But it also depends on technology. You know, shale oil was not oil until it was technologically feasible. So it was oil, chemically speaking, but not for our purposes because it could not be used. Now it can. So technology can increase, in inverted commas, the amount of oil that we can use. And of course the price. At current prices, shale oil has stopped growing. But if you put oil at 200, you will see a lot of shale oil coming back because, you know, marginal fields. Of course, there is a limit to that because there is the oil that there is. But typically, in an oil field, you get much less than half the amount of oil out of it because it's very difficult. And obviously, as the price of oil goes up, it pays to do more and more complicated things. Now, what people do, for instance, when an oil field is going down, you start injecting water or CO2 to pump the oil up. Now, this is very expensive, but if oil is expensive, then you do it. If it is not, you don't. So the amount of oil that you get out really depends on the price, as any economist would tell you. So now, whether Russia invades Ukraine, etc., well, that's pathetic for Ukraine, of course, but this is, at the end of the day, this will last whatever it lasts, but not 10 years. So these things are short-lived. What matters is how much oil there is, what is the technology, and what is the price. So, to conclude and finish, forecasting is difficult, especially about the future, as they say. Much easier to forecast the past. But you can be pretty confident of two things. Demand, contrary to the narrative, is not going down, and supply is. So, and these two things are fairly clear. And both demand and supply are very inelastic. That means, in economic terms, that when there is a small shortage, the price goes to the roof. Because how much will a Migros pay to get the food delivered? Well, they will pay whatever it takes. I mean, the option is to shut down. They will pay whatever it takes. Now, if diesel goes twice as high, 3 times as high, 4 times as high, it's not optional. So that's called inelasticity of demand. You know, you may not go skiing if it is extremely expensive. Then you would, that demand is elastic. But you will pay for food for your family. That demand is inelastic. And most of the demand for oil is very inelastic. But there is a lot of short-term volatility. You know, China is going up, so wow, let's get long oil. Now it's going down, let's short oil. So you see a huge short-term volatility, which puts off many, many investors, because I feel very stupid when I come here and say all of this, and then tomorrow oil drops 15%, which it does from time to time. I mean, Russia decides to stop the invasion of Ukraine, and oil may go down 15%. And then you could say, hey, you know, everything you were saying, look at my investments in oil. But that is very short term. That doesn't change anything about the long-term supply and demand. But it puts people off this kind of investing. Now, and this is the last point. What this makes is, in technical investment terms, the cost of equity of these investments is very, very high. These companies are always cheap because people don't want them, because you get all kinds of volatility, all kinds of doubts, all kinds of things. But that means that if you are right, high cost of capital means a big return for the capitalist. That's what it means. High cost of capital means that the companies must give a lot of money to the capitalist, which is us in this case. Petrobras paid, this, nobody believes this, 40% dividend yield last year. So that's a nice cost of capital. I mean, very bad for Petrobras, excellent for whoever invested in Petrobras, obviously. And doesn't have Geneva taxes, but that's a different issue. So this is the essence of the opportunity. If the cost of capital is very high, but it is very high for some reasons, which you don't agree with, and you are right, well, then you make an enormous amount of money. Voila, that's what I had to say.